Howdy and welcome back. In this video, I'd like to introduce the catch2 unit testing framework for the C++ language. Catch2 is pretty simple. It's defined more or less in a single header file, which makes it very easy for us to include into our various projects, which we will be doing so in the next couple weeks within this class. In fact, we're going to require that you write unit test for each of the MPs that you submit for a grade here. So in this video, I want to introduce you and get you acquainted with catch2. But before I do, I'd like to go ahead and explore how the directory structure is going to change as we get into more elaborate machine problems, and then also for perhaps more elaborate projects that you might become involved with. So I'm going to go ahead and jump over here to my Microsoft VS Code. There's a make file up, but if you can see here over in the left panel of VS Code, you can see that the directory structure that we're working with has a couple of folders that are new and different from the flat directory structure that you've worked with so far in this course. We can see a folder titled Ben. Ben is going to store each of the executables that are generated from the code within our project. So this might be a.out if we're compiling source code with a main function. In addition to this, our test suite is also going to, our test executable is also going to be created within this directory. The next directory that you'll see here, going in alphabetical order, is the includes directory. This is where all of our header files are now going to be placed. Likewise, for source files will go into the src directory for source files, src source. Finally, everything associated with our testing is going to go in the test directory. And we'll get into this a little bit here, but you can see right there the catch.hpp. That is going to be the catch2 framework. It is not going to be a file that you're going to write, but it will be one that is provided to you. Test.cc, as we'll come to see here shortly, will be the source file containing all of the tests that are composing our test suite for the particular project that we're working on. So I'd like to go ahead and just continue on this journey and explore what we're working with. To keep things simple, we're going to define a single function, factorial. It's going to return an unsigned integer value, and it will take as its argument a single unsigned integer object, which will be the integer value for which we are computing the factorial. So notice here in this header file, factorial.hpp, that is in the includes folder. So if we go ahead and look at the root of our project, ls, to list the contents of this directory, we see the make file, we see the bin directory, the includes directory, the source directory, and the test directory. Right now, we're in the includes folder. You can see here is where this factorial.hpp header file lives. As with any header file, we're going to go ahead and include our include guards. So if not defined, we're going to define this preprocessor variable, if you will, factorial_hpp. Again, this is by convention based on the name of the file. And again, by convention, for all these kind of preprocessor variables, they would be in uppercase. So if that's not defined, in other words, if we haven't seen this header file before, we'll go ahead and execute what's within the body of this preprocessor if statement. So we'll go ahead and define a preprocessor variable. So this ampersand, if you see that, it's dealing with the preprocessor stage of the compilation pipeline. So we'd go ahead and define it, factorial_hpp, and then the next time that if this file was included in the same translation unit, well, it would have already been defined, so we do nothing in that case. But first time through, we are going to get into the body of this if statement. We'll define that preprocessor variable, if you will, and then we'll begin bringing this file into wherever it's included. So in this case, all that's within this header is a declaration for our factorial function. Now, if we come down to the source folder, so I'll go ahead and back out in the command line, back to the project root and cd into the source folder, type ls, and you can see here we have two source files. One is going to be the corresponding source file to our factorial.hpp header file. Factorial.ccc is going to be where our definition of our factorial function lives. You can see here, and the astute student may realize this definition is not quite correct. That is intentional because we're going to use this as an example for unit testing this actual function. So we're going to write a number of kind of different asserts, but in a within the scope of our test framework to ensure that, hey, our implementation of factorial is correct and does compute the expected value. Okay, so here's our definition of that. We'll go ahead and roll with it as defined. Once we kind of isolate where that error is, we'll go ahead and update it so that it is correct and show you the kind of process of going from the case of all green and recognizing that, hey, our tests are only as good as we write them, to adding in an additional test that will catch kind of the edge case of this. We'll see those tests will go red. And then finally, once we update our implementation, we'll see the test suite will go back to green. Okay, so looking here, and if you recall what, here, let me give a more formal definition of factorial. It's simply going to be the product of an integer and all the integers below it. So if we were computing factorial 4, what we'd expect factorial to return would be 4 times 3 times 2 times 1. One important note to, I guess, consider here is that our definition of factorial is recursive, and I'd go ahead and encourage you to kind of map this out and perhaps catch the problem with it before we get into it. But anyhow, let's jump over to our main function. Notice here we're kind of doing nothing at this point, but we have expressed that we will be using our factorial function because I have included its declaration by including the factorial.hpp header file. So let's go ahead and write out some code real quick here to kind of preliminarily test our implementation as you might have to date. And then we'll go ahead and show how we could take over these output statements in, say, from main and put it into our unit testing framework and show kind of the power of containing our test cases within it. So give me one moment to type this out. I'll go ahead and compile this with you. Then we'll take a look at our make file. And then thereafter, we'll actually get into the test suite. So I'll be right back. Okay, so let's just go ahead and output the values of factorial 1, factorial 2, factorial 3, and see whether or not they meet our expectations. So to compile this in this non-flat project directory, I'm going to move into the root of our project. So if I go ahead and type ls, you can see I'm within my catch2 folder, where my makefile bin include source and test directories live. So to compile this, I'll write out clang ++, go ahead and express that I'd like to use the C++20 standard. I'll go ahead and specify that one of the directories that I would like to search for header files in is going to be my include. So that's going to be the I flag followed by the directory that we'd like to search for header files, because again, these aren't going to be in this, the header files aren't in the same directory as our source files. And that is the first place where we're going to check for those. If it's not there, it would then kind of follow through and search in the includes directory provided by us, then provided by the system. So then, okay, I've specified where my includes might be. Let's go ahead and compile source.ccc, and because we're using this factorial function, well, we also need to compile its definition because it resides in a separate file. Remember, this include statement is only copying and pasting the contents of factorial.hpp into main, so that as this main.cc source file moves through the compilation pipeline, particularly at the compiler stage, it can check to ensure that, hey, this name is being used correctly. And then once we hit the link or stage where kind of all the object files for our source file will meet and then be organized and packaged into our executable, well, we need to ensure that the object code containing our definition of factorial gets there as well. So I'll go ahead and include factorial.cc as a source file that I'd like our compiler to go ahead and translate. I'll go ahead and specify that the output of this compilation is going to go to our bin directory, and we'll go ahead and name it main. Okay, so let's go ahead and hit enter. Hope that I typed it all out correctly. I did, and we can see here up in bin, an executable named main has been delivered in. To go ahead and run that from the root, we have to specify that the executable is in the bin directory. Go ahead and write main, which is the name of the program we'd like to go ahead and execute, enter, and we can see here we have some values. So factorial of 1 is being computed as 1, factorial of 2 is being computed as 2, factorial of 3 is being computed as 6, and all of this looks good. So far, we haven't ran into our error yet. Now, we talked about asserts within our kind of week on testing. And I'll go ahead and just update this with some asserts so we can see how they kind of pollute and become intertwined with our code as we're going through this. And then I'll begin moving our kind of asserts over within to the unit testing framework. So give me a moment to write this out and I'll be right back. Okay, so to go ahead and include the C asserts, we go ahead and include the header file C assert. And then I went ahead and wrote a couple of assert statements to ensure or check whether or not the output of my factorial function meets my expectations. So remember, these assert statements are nice because we can kind of assert our expectations at a particular point in our program. So here I have the first statement on line 8 is simply asking, or I guess saying, hey, factorial of 1 should equal 1. The assert on line 10 is saying factorial of 2 should equal 2. And that on line 12 is saying factorial of 3 should compute to the integer value of 6. If I go ahead and compile and run this, all of these assert statements are going to evaluate to true, so we're going to have no disruption to the execution of our program. If I had said, maybe let's just to show an example here, I'm asserting that factorial 1 is equal to the incorrect value of 2, so that's kind of my expectation at this point on line 8. If I were to compile and run that, remember that an assert statement is going to kind of disrupt the execution of our program. And we can see here that, okay, we printed 1 here, so we hit that statement. And then when the runtime system was evaluating line 8, our kind of expectation of the world at that point was not met. Factorial of 1 did not evaluate to 0. Therefore, this conditional check, this test of equality, was false, and a false response will cause that assert to fire off this kind of chain reaction, disrupting the normal execution of our program. And we can see that here. Right after that statement, we see things begin to get a little hazy, and that this assertion failed, that on line 8 of main.cc, in the main function, assertion factorial of 1 equals 0 failed, and then, okay, execution of our program has been aborted. So I'll go ahead and change that back to 1 to correct that. But assert statements are totally useful as you're kind of running through your program. Feel free to include them to verify that where things kind of are meeting up to your expectations at that point in the program. Okay, so now let's go ahead and look into, well, I guess before we do that, I'll go ahead and just say we could use an assert statement for, say, the preconditions of a function to ensure that the arguments are kind of meeting our expectation, as well as maybe an assert for the post condition of our function, so right before we return, to ensure that everything's kind of meeting our expectation. But how do we actually test the implementation details? Well, we could go ahead and write some unit tests, which would provide kind of inputs into this function factorial. So maybe the integer value of 1, 2, 3, and then a way for us to go ahead and check kind of in a similar fashion to here, but without polluting our source code, to ensure that, okay, hey, the implementation is computing the results that we're expecting. And the nice thing about using this unit test framework is that these sorts of implementation tests will be removed out of our source code, and they will be placed within a test source file. The other nice thing is that we will not need to compile kind of the full program. Instead, we'd be able to simply compile the source files that we're interested in exercising. So in other words, the catch2 framework will provide a main for us. It will compile the source files that we would like to test, and it will go ahead and create a test executable, which will run those test cases for us and provide a nice output determining whether or not each case passed or failed. Okay, so I'm going to pause here, take a quick break, and then I'll run right back and we'll continue on with the test files. Okay, so at this point, I'll go ahead and kind of acknowledge where we're going with this. So let me pull up the catch2. So I guess this is the tutorial, but there's also the documentation here as well. If you're interested in kind of looking at the full power of catch2, so everything that you can do with it, which will exceed what's being introduced today, you can go ahead and open up the catch2 reference documents. It's in the GitHub repository, the catch org within catch2. And once you get there, you can navigate into the docs directory. And you can see here, they have a nice reference, and then they also have a nice tutorial. And if you look at the example, it's kind of similar to what we're doing here. So we're going to be concerned with kind of the equivalent of the assert statement within our testing source file. We'll see here that there's a lot more elaborate things you can do with it, which may make more sense as we progress through the semester. There might be some very powerful things that you can pull in from here to test the more elaborate programs that you'll be writing as solutions to our machine problems. And I will do my best to remember to kind of point you in the direction where it's relevant. But let's keep it simple today. So we'll hop back over to VS Code. And let's now kind of divulge into this test directory. So if you remember here, show you where we are. The catch.hpp source file is going to be provided to you every time by us, or you can download it yourself through GitHub. And since we're not releasing it on the, I guess, first and second MP, depending on the semester, that might be wrong, but we will reach a point where you'll see this familiar directory structure. And at that point, you'll see in the MP documentation, oh, I'm required to write test cases. Cool. But if you're interested in experimenting with this on your own, or even before those MPs are released, I'll post this header file to the forum, and then you can also view the documentation and experiment. But again, this is provided by the Catch organization. There's no reason for us to look at it outside of just acknowledging that it's here. So you can kind of view this as a black box of sorts. We're relying on it, but we're not going to get into the implementation details as to how this framework is actually implemented. Instead, we're going to go ahead and concern ourselves with the test source file. I've gone ahead and put this in the test directory, which makes sense. Let's go ahead and put all the kind of testing stuff within that directory test so everything stays organized. Test.cc is going to be the file that you will generate. And it's going to take a little bit of configuration first, which is to set up the framework. Here's a preprocessor directive that I'm not going to get into here. If you're interested in precisely what this is doing, it is within the documentation. So these 3 lines here are necessary. The 4th line here is also necessary, and this is including the actual framework as it's defined in the catch.hpp header file. Everything after this is going to be our own code, okay? So we're setting up the framework, and then if we're interested in expressing or testing rather our factorial function, well, we need to go ahead and introduce its name to the compiler, to this translation unit. So we'll go ahead and include factorial.hpp. Again, so when test.cc goes through the compiler stage of the C++ compilation pipeline, it will see how factorial is to be used. So it's a function. It returns an integer value. It takes a single integer parameter here. Okay, cool. I can perform my type checking before I begin converting this into assembly, then object code, and then kind of aggregating everything at the linker stage and creating that executable. Cool. Okay, so at this point, we're ready to begin writing our first test case. So let me go ahead and begin writing this out quick, and then I'll kind of decompose it with you. All right, so this is from the documentation. We're going to create our first test case, and we could have split this out across kind of multiple test cases. I'm going ahead and putting it within one. So to tell catch2 that we're creating a new test case, we're using this test case kind of as the name of the entity that we're constructing here. The first argument is going to be kind of a descriptor to communicate what's being tested. So in this case, factorials are being computed. And then the second argument here is simply kind of an identifier for this. If we wanted to run this test case independently of all of the other test cases, we could go ahead and use this particular identifier here, factorial. Now within the body is where we're actually going to begin writing our test cases. I guess how we can view this require statement is similar to an assert statement. So what we're saying here as our kind of first component of what's being tested in the factorials are computed test cases, we're requiring that factorial of 1 evaluates to the integer value of 1. If this test of equality is true, we will pass this particular requirement statement, move on to the next, similar to kind of how things were working with our C asserts. The nice thing though with the test2 framework is that if one of these fails, so if a false value is returned, this test case fails. But if we had multiple test cases defined, like let's go ahead and say factorial of 2 evaluates to 2. Whoops. So we could say factorial 2 as its name. And then, I don't know, let's just take it out of this. Okay, so if, let's say this test case failed, this test case would still be executed. So notice here that to introduce an additional test case, all we're writing is test case followed by a description, followed by an identifier. And then within the body, if you will, of test case, we're simply defining what we're checking and how we're going about that. So I guess I should have removed this too as I was talking to show that, okay, that was, simply looking at factorial of 2. But I'm going to go ahead and keep all of this under one test case for now, but simply kind of following this pattern would allow us to introduce additional test cases into our test suite. Okay, so we've got these, our first single test case here defined. Let's go ahead and compile it. So I'll go ahead and move back to my root directory here, and I'm going to write out our compilation command. We're going to compile with this C++20 standard. I'll go ahead and provide that flag to say that, hey, header files might reside in this includes directory. And now what are the source files that need to be compiled? Here, we're going to compile our test source file. And since our test source file is exercising our factorial function, we need to also pass the definition of that function to the compiler, and that lives in the source folder, and it's named factorial.cc. Let's go ahead and route the executable to the bin folder, and let's call it test. And let's hit enter. Hope that all this goes well. If not, I'll pause and come back to y'all. But yeah, this should compile. It does take a little bit of time, but if you look right up here, you can see that, okay, test an executable file is being made. You can see it hanging, so it's still putting it together, and then it will eventually result. Let me pause here. All right, so if we want to go ahead and so you can see here that the compilation of our test suite has finished. If I want to go ahead and execute our test executable, that's going to be /bin, we named it test. And then if we go ahead and look here, we can see that all of our test case passed. 4 asserts, 1, 2, 3, 4 in one test case. Well, one test case, all passed. So the nice thing about this is that if we kind of compose all of our test cases within this test source file, we can execute them anytime we'd like. And actually this provides us a means of performing a sort of regression testing on our source code as well. So, at this point, we're kind of confident that our factorial function works. If we were to go write, additional code elsewhere and bring this function in, well, each time we'd write test cases for that, those and other implementations as well, but we'd also write test cases within this file. So every time we're executing our test suite, we're not only executing the test against the code that we've maybe just written, but also against kind of all of the code that we've written to that point, provided that you are following kind of test-driven development and not writing all of these after the fact. One key thing to note, though, is that the test suites are only as good as we've written them to be. So in this case, if we go ahead and look at our definition here, something's not quite right with it. And there's kind of an edge case that's missing here. So let's go ahead and consider that edge case. So we'll require that factorial of 0 is equal to 1 by its very definition of factorial. So I'll go ahead and find it, compile here, and then we'll go ahead and see what happens to our output of our test suite at this point. Okay, so this is compiled. Let's go ahead and run it. We can see here that our test suite did not pass. Factorials are computed, so this test case failed. So we can see here test case 1, so we had one failed test case on one assertion. Okay, so we'd have to do some tracing here, some debugging to isolate, okay, well, what was actually failing, or we could have organized our test suites a little bit more independently so that maybe we had a factorial of 0 being tested, and then so like separating the edge case from the more general cases might have been one approach to do that. And I'll go ahead and do that right now just to show you how that affects the output. So give me one moment. Okay, so I've updated our test source file to have two test cases now. So one's kind of examining the output of factorial for, I don't know, the more, we'll call them general cases here. So positive numbers greater than 0. I then moved that factorial of 0, which is kind of a, I don't know, special case when it comes to the computation of factorials of, some number into its own test case here. So factorial is computed for edge case factorial of 0. And you can see here that both of these test cases have unique kind of identifiers for them. So I've gone ahead and compiled our test suite. Let's go ahead and execute it. We can see here the output notifies us that factorial is computed for the edge case factorial of 0 failed. And then we can see here that simply because this test case failed did not prevent the execution of the other test cases within our suite. So we can actually, we have some information here in that test cases 2 were executed, 1 passed, 1 failed, and a total of 5 asserts were checked, 4 of which passed, 1 of which failed. Okay, so this is all looking good. Let's go ahead and modify our source code, our definition of factorial to return the correct value. This update here. And then after modifying my definition, and again, so keep in mind, testing is simply telling us, whether or not our implementation is correct. Debugging is the actual process of going in and figuring out what's wrong and what's correcting it. And that's where the fun begins. You might write a test case, you have some sort of expectation, you execute your test suite, and something you thought would pass failed. Next step is go track it down. Here, I know what was wrong. I know, because it's an example, I know what this should have been changed to. So I simply am going to implement that change and then go recompile our test case so that you can see kind of the process of going from this unfriendly red to a more satisfying green to acknowledge that our test cases have passed. Okay, so with this change to our definition of our factorial function, we can go ahead and re-execute our test case. And notice here that we didn't have to feed anything into our program. We didn't have some sort of long list of test cases that we were polluting our main with. We simply executed this test suite directly. So it was, very quick. Once it was compiled, it got straight to the point, executed the two cases that we had defined. And we can see here that we correctly implemented our factorial function to the extent of which our test cases have exercised it. So everything, has now gone to green. We're good. We can continue on writing, some additional code here, which I'm not sure which direction we're going with this kind of trivial function, but you can kind of see the process. It would be, write some test cases. Go ahead and begin writing your definition. And then as you're going through it, maybe you solve for the general cases first in your definition of factorial, right? So you go ahead, you see, okay, I'm green, but I still need to consider the edge cases. So then you'd go back to your definition, you'd make some changes, you'd go ahead and save it, and then just go ahead and recompile your test suite, and then go ahead and execute the test. And the idea here is you kind of start out all red, and then you begin moving and iterating towards green. But again, the correctness that we're testing for here is only as good as the test cases that we've crafted. So the last thing I'd like to go ahead and do here is simply update our make file so that we're able to make our executable, and just have this process a little more streamlined. So what we're looking to create here is going to be our test executable. So we'll go ahead and say we're looking to create test.out. This is going to be dependent on tests, and then test.cc. And then also remember, because we are exercising that factorial function, we also need to compile its definition. Okay, so this recipe is going to create the target test.out, and it is going to do so based on its dependencies, test.cc residing in the test folder, and then the factorial.cc source file residing in the source directory. Notice here this is a variable here. It's evaluating to Clang++, so you can read this as Clang++ followed by this long list of flags, followed by this kind of includes, which is just going to be included by default here. And then this is saying we're simply sourcing or compiling these files here, and the output is going to be named that. So that's kind of how we're putting it together. The last thing we're going to go ahead and do here is say that, okay, our test target is going to simply run our test executable. I believe we need a dash here. Okay, so before we begin this, I'm going to go ahead and from my root directory, write make, and then I will go ahead and write clean to execute this recipe, which is simply going to clear out our bin directory. And then I'll go ahead and attempt to make our test. And then we can see here, I made a mistake somewhere. This gets me every time. Let's go ahead and make the test target test.out plural, close to singular, try and make test again, and we can see here, this is what's being, the command that's being executed when we are making our test.out file. So you can see here that Clang++ followed by all of our flags, followed by our includes, and then you can see that the source files being compiled are as specified. And then we can see here, the output is going to be that bin/test.out. And look, lo and behold, that executable got written to our bin directory. And then the last thing that our make test does is, well, okay, test was dependent on this, which was not created. So we had to execute the recipe for that, which resulted in the compilation and creation of the test.out executable. And then all the test recipe here is doing is executing that executable. Cool, and we can see here in this case all of our test case passed. And if we wanted to create, or run our main, it's just main execute or make executable. We can see here that's running as well. So now you have two useful make targets. You have an ability to quickly make and execute your test cases, as well as make and execute your program, as well as some housekeeping functionality to clean up that bin directory. And as you know from the make discussion, this is a very powerful application, and there's a lot that you can do with it. So this concludes our introduction to the catch2 framework. I hope it was productive and that you learned a lot in the process. I will go ahead and make these files available to you, and I'll provide a link somewhere on the page where this video is being presented. So thanks again. I hope you learned a little bit about catch2 and that you can see the utility of incorporating it into your projects moving forward.